Three numbers whose product is the biggest possible from the array. Here's the narration. Here you're given a list of whole numbers, and your job is to pick three of them that multiply together to give the largest possible result. Once you've found that trio, return their product. aka advanced level, you know this one. Top 3 fails the moment too large. Magnitude negatives multiply into a positive. The interesting part isn't the trap, it's articulating why max top 3 neg barely max is probably exhaustive. That's where we're headed. The real claim to defend in an interview after sorting, the optimum is exactly one of two configurations. Any winning triple has an even count of negatives among its factors, so it's either 3 from the right tail or 2 negatives from the left tail times a single max. No third case survives. Before coding, nail the constraints you'd ask about, exactly 3 elements and at least 3 guaranteed, and value bounds. With values up to 10 sec 3 and n up to 10 sec 3 and n up to 10 sec 4, the max product fits comfortably in 64-bit, so no overflow talk needed in Python, but flag it for C++ or Java. The all positives only solution is sort and take, talk 3. Say it out loud in an interview precisely so you can immediately name its failure mode. It silently assumes monotonic sign which the negatives break. Naming the assumption is the signal you understand the invariant. The witness, -9, -8, 1, 2, 3. Top 3 yields 6, the negative pair times max yields 216. This single input is what forces the two candidate formulation, and it's the input you'd cite to justify the extra branch. The whole solution collapses to sort, plus a single max over two products. Worth noting, sort is only here to expose the two tails cheaply. If you're asked to drop it, the linear scan variant replaces it with 5 running extremes, same two candidates. State the invariant cleanly post sort. No interior element can beat a tail element in either candidate, because swapping any middle factor toward a tail is monotone, non-decreasing in magnitude with sign fixed. So the search space is 2 triples, full stop, regardless of n. In place sort n log n. If the interviewer pushes on space, note this, mutates the input, use sorted if the caller can't tolerate that. After this, the two tails are addressable by fixed index, which is what makes the next line branch free. 2 products, 1 max. Note there is no third candidate for 2 negatives. Times second max, since the second largest positive never beats the largest, and the all negative case is already covered by top 3. That's the subtle correctness argument most people skip. Quick dry run. For -5, -4, 1, 2, 3, decide which branch wins and by how much before scrolling. If you can call it instantly, you've internalized the invariant. Low 2 wins at 60 against top 3 6. Textbook case where the negative pair dominates. If you predicted the branch and the margin, you're ready for the follow-ups. The expected follow-up, drop the sort for a single pass maintaining max 1, max 2, max 3 and min 1, min 2. Linear time, constant space and its streams. The gotcha is initialization, seed the maxes to negative infinity and the mins to positive infinity or all. Negative input silently corrupt the extremes. N log n versus n is a non-argument at n up to 10 set 4, both are microseconds. The scan only earns its complexity if the input is a stream you can't hold, or n is huge and you're memory bound. For the graded submission, sort and move on. Cite the scan only if asked to optimize. The classic failing inputs, all negatives, where top 3 correctly returns the least negative triple and any top 3 only solution passes here. But the two-corner check is what keeps it robust across mixed sign. Zeros need no special case. They just lose to any positive product. And exactly 3 elements must return their product regardless of sign. Verify your indices, don't assume n greater than 3. The real interview escalation, maximum product of k elements. Now you compare up to k over 2 candidate splits, pairing an even number of small negatives with large positives at each step. The two-corner idea generalizes to a tail pairing sweep. Tomorrow's problem applies the same extremes. At the corners, reasoning to a much harder subarray variant. You made it to the end, that's the hard part. Liking and subscribing is easy. Given -10, -9, 1, 2 and 3, what's the biggest product of 3? Pause and take a guess. Don't just grab the 3 biggest. Those 2 negatives might be plotting. It's 270. From negative, 10 times negative, 9 times 3. 2 negatives multiply into a large positive. How many candidate products do we really compare? And what does that cost us in time? Pause and think. You don't need to try everything. It comes down to just the ends. Just 2, the top 3, or the 2 smallest times the largest. One linear pass finds both, so it's O of n.